The facts about yesterday's storm are staggering.
Sub-zero temperature.
A mountain of snow making roads impassable.
Something is up with the weather.
I'm weatherman Alex Beresford, and in this series I'm investigating why Britain's extreme recent weather has been so bad.
Hailstones coming through open windows last night.
I'll be looking at floods.
Oh, I can't believe it!
Dangerous storms. Intense cold.
It's Armageddon, I'm telling you, this is the end of the world.
And baking heat. To find out why weather creates headlines like never before,
West Coast are flooded.
here is where the battleground is going to take place. I'm trawling through centuries of British history and seeking out the science that can now help to provide answers. I want to discover if our weather is getting worse. And this time, I'm investigating winter cold. Although the start of 2014 was wet, stormy and mild, in the last few years our winters have been dominated by seriously cold weather.
Whoa!
In 2009 we were hit by the coldest winter in over 30 years. In 2010 we were blasted by the coldest December in over 100 years. And in 2013 we suffered the coldest March since 1963. To find out if we need to get ready for more winters like that, I need to search back through history.
5 weeks of frost, even the sea frozen over.
And investigate the latest research that may have found vital clues, not on Earth, but millions of miles away on the surface of the sun. It's a complex system, but finally, scientists are beginning to understand what's really going on with our winter weather. After a winter of storms and floods, it's easy to forget that less than 12 months earlier, it wasn't water covering the country, but snow and ice.
Oh, here we go, proper sideways. Sticky over birds!
In 2013, Britain was hit by the coldest March in 50 years. When Easter came at the end of the month, it looked more like Christmas. In fact, it was the coldest Easter Sunday on record, with a low of minus 12.5 centigrade in the Scottish Highlands. Why it got so cold so late in March is a complex question. There are many forces driving the weather.
The biggest factor that controls our weather is a fast-flowing wind high up in the atmosphere. It's called the jet stream.
Britain is part of a giant global weather system. Air circulates in the atmosphere. Warm air rises, moves north, cools, and sinks in huge horizontal bands of air that circle the Earth. There are 3 in the northern hemisphere and 3 bands in the south. And where there's a junction between these air masses, powerful winds are created high up in the atmosphere. These are the jet streams. They snake round the Earth from west to east, travelling in waves at speeds of over 200 miles per hour. The jet stream that influences our weather is called the polar jet. It flows at the same altitude as airliners, and that's why flights home from New York are much faster than going the other way. But the jet stream doesn't stay in the same place. The waves move, and as it moves, it has a big influence on the temperatures here in Britain.
The jet stream blows along the boundary between the cold polar air to the north and the warm tropical air to the south. When the waves change shape and move, the air masses move as well.
In winter, the jet stream normally passes to the north of the UK, but sometimes it moves south. Then cold air from the northeast is sucked down, sending temperatures plummeting. And that's exactly what happened in March 2013. The first wave hit the south hardest. Between the 10th and 12th of March, snow combined with strong winds led to bitter conditions and transport chaos. But the worst blizzard began on the 22nd. The temperature reached -3 degrees centigrade and the winds gusted at gale force. High ground in Scotland, Northern England and Wales got the brunt of it, with up to 40 centimetres of snow. And then the wind blew it into massive drifts. In the hills near Llandudno in North Wales, farmer Gareth Wyn Jones was facing a desperate situation. On the morning of the 23rd of March, parts of his farm had disappeared under snowdrifts up to 4 metres high.
I've never seen anything like it. It was so powerful. You felt a little bit helpless because you can do everything, but you can't fight nature, you can't fight the weather.
But Gareth did have a battle on his hands. Over 200 of his mountain sheep were missing. When the blizzard began, they went behind the stone walls to shelter from the wind. But the snow was drifting so fast, they were soon completely buried.
Along these walls would have been the majority of the sheep. And you've got to imagine the snow would be up here. This is how tall the snow would be. So the sheep would be down here.
Which meant Gareth had to dig each of them out by hand. It was a race against time. Their thick coats could keep the ewes alive for 2 to 3 days, but then they start to die from cold and hunger. And the blizzard came at the worst possible time, lambing season.
80 ewes are lost, but we're talking about hundreds and hundreds of lambs. And it was probably, for me as a farmer, the worst thing was to see the sheep that were trapped and they'd given birth in their cocoons, the igloos they'd made for themselves, but they couldn't turn around. If they could have turned around to lick the little lamb, them lambs would have lived. And that was very, very difficult to be finding the sheep, and after digging them sheep out, what you always found at the bottom was the dead lambs, and that was tough.
With many of the sheep completely hidden under snow, the death toll could have easily have been much worse. But Gareth got help from the hill farmer's best friend.
The old dog sitting in the back of the Land Rover cap, he saved over 80 ewes. He found them. All he was going was by smell. He would walk all these walls with me and a few of my friends, and he would find an air pocket, an air hole, and he would smell it and he would start scratching. Then we'd get the spades out and we would just dig and dig. And that had to be done not once, twice, but 80 times. You just think of the severity. It was absolutely physically, mentally, emotionally draining. Very, very tough times. And for many farmers in North Wales and over Britain as well, I think a lot of people will never get over that. Never get over it.
Gareth had never seen anything like the snow of March 2013. It led to tragedy because it formed drifts faster and deeper than ordinary snow. Now I want to discover what made it so treacherous. To find the same kind of snow that hit Gareth's farm, I've come to the Cairngorms in Scotland. The altitude here means they get snow every winter, making this one of Britain's most popular ski resorts. Recently, the skiers have enjoyed the best conditions in years because what fell as rain on the rest of the country fell up here as snow.
To most of us, snow is just snow, but it actually comes in many different forms, and that's why people in the Arctic have dozens of different names for it.
Nick Bullivant knows everything about snow. He's head ranger in the Cairngorm National Park.
The surface snow is like, almost like dust.
Yeah.
I think there was a small shower this morning, and you see that?
Yeah.
That is almost the snow crystals.
So what's the difference between the snow that we've got here at the top of the mountain and the snow that falls in towns and cities?
Well, it's a lot colder up here for a start. Most towns and cities are naturally a little bit warmer. It'd be hard put to make a snowball out of this snow. Down in the towns, it's usually relatively easy to make a snowball or a snowman because the snow stick together. So it's not so much the location, it's to do with the temperature.
Snowflakes form when it's very cold, high in the clouds. But at lower altitudes, the air is usually a little warmer. So as the snow falls, it starts to melt just a little, which makes it sticky. And that makes the flakes bind together, so it doesn't get whipped up by the wind. But if it stays really cold, all the way down to the ground, the snow is fine and powdery, and it soon starts to pile up into drifts, which is how the sheep got buried on Gareth's farm.
It's quite pleasant stuff in some ways. It's not pleasant when it starts blowing and then it goes into everything and it goes into your clothes and into your face. While it's drifting, you can't see what's beyond the drift. It is very alarming.
This fine, powdery snow can be a menace in other ways. In fact, it has been called the wrong kind of snow. The phrase was coined in 1991 to explain what had brought British Rail's newest trains to a standstill. The new engines were built to be snowproof, but their air vents kept getting clogged with this powdery snow. And 22 years on, the wrong kind of snow again caused travel chaos on our roads, railways, and airports.
The cold snap of 2013 took the country by surprise and brought much of it to a standstill. But to find out how unusual this type of cold spell was, we need to look back at British winters of the past.
"2014 came in with a bang, but a year earlier it wasn't storms making the news, but blizzards. In fact, in 2013, we had the coldest March for 50 years. Now, I want to discover if that extreme weather was just a blip or part of an underlying trend. To do that, we need to look back at previous bad winters to search for patterns and try to work out what caused them, starting with the worst winter for almost 30 years.
The winter of 2009-2010 was known as the Big Freeze. Average temperatures were the coldest since the 1970s, and widespread heavy snowfall and plummeting temperatures brought havoc, shutting down roads, railways, and airports.
For a third consecutive day, the reputation of Britain's busiest airport was buried under piles of snow and ice.
Conditions everywhere were painful. In Scotland, the thermometer plummeted to -22 centigrade. In Hampshire, over 1,000 motorists were stranded overnight on the A3. And across the country, football matches were postponed. Oldham Athletic couldn't play at home for 6 weeks.
This is known to be the coldest club in the country, but even by their standards, this break in play is unprecedented.
In January, the Christmas holidays went on and on as thousands of schools remained shut, while 20% of the nation's workforce was trapped at home.
Just trying to get a shovel now to move all the snow and hopefully be able to get going. Otherwise, back home, no work, no money.
Satellite images revealed something very rare indeed. The entire UK was covered in snow. And the winter of 2009 to 10 was different for March 2013. It wasn't a short, sharp freeze, but a whole season of ice and snow. It started in the same way when the jet stream drifted south, allowing a blast of cold air to come in from the northeast. But then it got stuck.
A huge rotating anticyclone built up, a mass of cold, dense air which grew bigger and bigger and refused to budge. It became unmovable and prevented other weather systems from hitting the UK.
And 2009 to 2010 wasn't the first winter this happened. These conditions are what lie behind all our longest, hardest winters, including the worst one in living memory.
"5 weeks of frost, even the sea frozen over. Southend Pier surrounded by ice floes, day after day with the mercury well below freezing."
The winter of 1962 to 63 was the coldest in over 200 years. Britain was hit by temperatures below -20 and winds gusting over 80 miles per hour. The snow lay on the ground for a record-breaking 62 consecutive days, and that January was the single coldest month of the entire 20th century. On the farm in North Wales, Gareth's father, Roland Wynne-Jones, remembers it well. He had to cope with deep snowdrifts from the middle of December until well into March.
In 1962, we lost about 45 ponies and about 100 sheep. It was a devastation, to tell you the truth. Well, I'm quite sure myself 62 was the worst one, because the blizzard lasted quite a long time and there was a lot of frost then. The water was frozen, the drifts was terrible. Can you imagine up here, the drifts? And they were around the farm, you couldn't move anything. Yes, we're very lucky to survive, yeah.
The freezing winter of 1962 happened when the jet stream meandered further south of the UK and became stuck. It created strong easterly winds, which in winter can cause a potentially dangerous problem: wind chill.
Wind chill is the result of a low temperature made much worse by a high wind, and it's easy to underestimate the danger. In January 1963, 6 young army recruits were sent out on a map reading exercise. Wind chill turned it into an exercise of survival.
On Dartmoor, a party of soldiers had a very narrow escape from freezing to death. After 2 days of blizzard and 18 degrees of frost, 2 of them were finally located and rescued by helicopter. They were in a pretty bad way, but not as bad as the other 4 who were found here in a deserted house. After their tent had blown down in the gale and their boots had frozen so that they were impossible to get on, the 4 men had struggled to shelter in their stocking feet. 3 of them had to be carried out to the helicopter. All of them were frozen stiff and had severe frostbite.
Wind chill can turn a low temperature into a dangerous force, and here in Britain, we're rarely prepared for it. As Darren Condon knows only too well. On the 23rd of March 2013, he and his mate Liam were on their way from Barrow-in-Furness in Cumbria to a building job in Whitehaven. As they reached the hills near Millom, conditions deteriorated fast. And they captured what happened on Darren's mobile phone.
Look at it streaming over the wall. It's Armageddon, I'm telling you, this is the end of the world.
And all of a sudden we kind of had to slow down. We realised that there was quite a lot of cars at the side of the road, lorries, things like that. And at that point we actually got stuck ourselves, and there was no way of us getting out in any way.
Snowdrifts were forming so fast that over 70 motorists were stuck on a 3-mile stretch of road.
This is the worst snow I've ever seen in my life. I ain't getting out of here. Oh, I've got a little bottle of water and I've got 4 little biscuits.
One option was to find shelter on foot, but the freezing temperature combined with the gale produced a wind chill of about -12.
When I got out of the car, the first thing you realise is the wind and the noise and you know, how cold it actually was. But literally within, you know, 5 or 10 seconds, you're just pretty much paralysed with the cold. It was just intense, something I've never felt before.
So wind chill had them trapped until almost 2 hours later, when rescue came in the form of a local farmer and his tractor.
That was an absolute legend on the day, it really, really was. And when he started attaching it to the axle of the van and pulling us out, you know, it was brilliant. It was a fantastic feeling.
Free of the drifts, they turned to head back the way they'd come. But by now, the snow had started to build up on that road too.
But as we were bombing along here, you know, we were just trying our best not to get stuck. And then literally, as we were coming around this corner right here, there was just an almighty bang.
Oh my God! What the f***?
A 1 metre high snowdrift had built up in less than 2 hours.
And we literally thought we'd hit another car that was under the snow. That's how loud it actually was.
Once again, they had to wait for rescue. They could see the drifts getting deeper with each passing minute.
I think that was an hour later, maybe a couple of hours later. You know, through the snow, you could see the flashing lights, and we thought the snowplow was here. Everything's okay. And he pulled up alongside of us. And at that point, again, we realised that the actual snowplow was stuck.
The snowplow's stuck. You know you when the snowplow is stuck.
And at that point, all hope had gone, you know, of us getting out. You know, people that were here on the day, it'd be very, very hard to imagine what it was like. Very, very scary.
Darren and Liam were trapped not by the temperature alone, but by the intense freezing power of wind chill. To find out what that felt like, I've come to a climate control chamber normally used to test cars in low temperatures and high winds.
Bit chilly in there. It's actually -2 at the moment. Nothing abnormal about that. Kind of typical of, you know, temperatures through a British winter.
But to reproduce the conditions Darren faced in Cumbria, we need to add the wind. We're starting the chamber's wind machine at 20 miles per hour.
Starting to feel like the wind is kind of going through me rather than around me. Yeah, that really is feeling quite raw now.
But where Darren was in Cumbria, it was gusting at over 40 miles per hour.
Okay, this is kind of getting close to gale force.
Which makes the wind chill more like -12.
Oh gosh, that is cold.
But how cold could Britain get? The lowest temperature ever recorded in the UK was at Braemar in Scotland, and that was -27.2 centigrade. So what would that feel like in a 40 mile per hour gale?
Wow. Oh, my nose. Oh.
The wind chill is now close to -50. In under 5 minutes, any part not protected will suffer from frostbite, where liquid in the body turns to ice crystals. Without gloves, I could lose my fingers. And without goggles, my eyeballs would freeze. That's too cold for me.
I'm so cold.
So trapped by the wind chill, Darren was right to wait until help finally arrived.
We noticed in the rear view mirror there was flashing lights, and it turned out it was mountain rescue in a big 4x4. At that point, you know, elation, we just couldn't believe it. And yeah, we were rescued.
Darren didn't realise just how narrow his escape was until he returned to find his van a few days later. It had been completely buried.
Yeah, it sent shivers down his spine, you know. There was no chance of you getting out. There's no chance you would have been able to even open the van door. You know, the petrol ran out, there was no food. Very, very dangerous situation to be in if we didn't get out when we did, really.
Freezing temperatures, biting winds and treacherous snow. The dangers of bad weather should never be underestimated. But looking further back in history, there was even a time when one of these extreme winters brought Britain to the brink of economic collapse.
Ships were loading coal at Newcastle, but many were held up by the appalling weather. Then it grew colder still, and no one could forecast the extent or duration of the crisis. The damage already done could not be assessed, but it was frightening.
In 1947, Britain was still struggling after the Second World War, when a long, bitter winter set in. That February was the coldest one on record, and snow fell somewhere in the country for 55 days in a row.
Over now to Trafalgar Square, where Nelson and the Lions watched the snowballers making good use of plenty of ammunition.
Out in the countryside, the cold killed about a quarter of all British sheep. Snow blocked roads and railway lines, cutting supplies of coal to the power stations. To save electricity, factories were closed, and that cost the country so much money that the pound had to be devalued by 30%. Just 2 years after the war finished, people were again sitting in the dark. 1947 was another winter when the jet stream got stuck to the south. So it's clear that the key to understanding our worst weather is to find out what makes the jet stream change course.
These extremely cold winters seem to crop up almost at random. But scientists are now beginning to understand the reasons one winter might be much colder than another. To find out why, we need to look back a lot further in time.
The British climate is one of the most variable in the world. And while the winter of 2013 to 14 was stormy but mild, before that, in 3 out of the past 5 years, we've suffered record-breaking cold snaps, blizzards, and big freezes. But are these just random weather events or part of an underlying trend? We need to look back through history to see if our winters are changing.
British meteorologists are lucky because we have this, the Central England temperature record, and it's a log of the mean air temperature in the Midlands, which goes back to 1659, which makes it the world's longest series of data observations. And what it does show is that there have been extreme winters, but also periods when the country was cooler.
And the best known of these is called the Little Ice Age. It started some time before these records began, and it ended in the mid-19th century. The average temperature in the Little Ice Age was only about 1 degree Celsius lower than today, but during those cooler centuries there were also shorter periods when Britain was hit by extremely cold winters. One of these periods came in the early part of the 19th century, when the author Charles Dickens was growing up. The weather then had a big influence on him. Dickens' childhood was far from ideal. Driven by debt, the family moved frequently. At the age of 12, whilst his father was in the debtor's prison, he worked in a factory. And those winters at the end of the Little Ice Age were bitterly cold. In fact, 2 out of every 3 Christmases were white. Later in life, Dickens remembered that cold, though somehow Christmas always had a rosy glow. They stood in the city streets on Christmas morning, where the people made a rough but brisk and not unpleasant kind of music, in scraping the snow from the pavement in front of their dwellings and from the tops of their houses, whence it made mad delight to the boys to see it come plumping down in the road below, and splitting into artificial little snowstorms. Passages like this have played a big part in creating our idea of the perfect Christmas, even though we rarely see a white one today. Dickens lived through the end of the Little Ice Age, seeing plenty of cold winters as he grew up. But going back further, there was a period with even colder winters than that. It started about 1650 and lasted over 60 years.
If I was standing here in 1684, the river would have looked very different. And that's because during the coldest winter ever recorded here in Britain, the Thames froze over. There was thick ice all the way down from bank to bank.
In fact, 1684 wasn't the only time the river froze, and when it did, London came to a standstill, and the frost fairs began.
During the mid-17th century and the early 18th century, the ice on the Thames was thick enough for at least 8 frost fairs, and these plaques commemorate them.
I'm meeting weather historian Ian Curry to find out what these frost fairs were like.
To see the mighty Thames all frozen or no difference twixt the stream and shore, the like no man has seen before, except if he lived in days of yore. It was a magnificent spectacle, and it would draw great crowds, and then that would also attract the street traders to come in. And so they would declare a frost fair, and you would have marquees set up where you could get a roast dinner or a fuddling tent where you could get beer, ale and brandy, and there would be sounds of music and revelry, and people would skate on the ice, and they could probably go about 20, 30 mile an hour, which was astronomical speed in those days.
It sounds like an exciting time, but it took some extraordinary weather for us to get to that point.
There were around about 22 cold or severe winters between 1650 and 1700, for instance. So we had occasions like in 1684, even the Straits of Dover were choked with ice. And in January, the Arctic ice had come so far south that even there were reports of, in the Northern Isles of Scotland, of polar bears jumping off and terrorising the crofters.
Really?
So this was cold times.
But the winter of 1684 wasn't all tall tales and frost fairs. No one knows how many people or animals died from the cold, though the diarist John Evelyn reported that all the birds in London were dead. But why were winters in this part of the Little Ice Age so hard? It's a difficult question to answer because the forces behind our weather are so complex. The Earth's climate is governed by many interlocking factors, from the hot air that rises in the tropics to the temperature of the deep oceans and the state of the polar ice. Any little change in these global forces can mean the difference between a heat wave and a hurricane. So when scientists went looking for the cause of the Little Ice Age, some latched onto volcanoes. Because it's long been known that large volcanoes can cool the global atmosphere by over ½ degree. This happens when an eruption sends millions of tons of sulfur dioxide into the outer atmosphere. Carried around the world by the tropical jet stream, it forms a veil that reflects sunlight away. That effect has certainly reduced temperatures in the past, and some scientists even think volcanic activity may have triggered the Little Ice Age. At the headquarters of the British Antarctic Survey in Cambridge, Dr. Clive Oppenheimer has come to look at some of the evidence for that theory. He's a volcanologist, and he's come here to examine ice cores from drill sites in Antarctica. The snow there never melts, but just gets compressed into layers of ice by the next year's fall. In places, it's now over 3 kilometers thick. By drilling down into it, ice cores can be extracted like frozen timelines. Back in the lab, minute traces of sulfur dioxide have been found in certain layers, telltale signs of volcanoes of the past, many of them unrecorded by history.
In this whole period of ice that we're looking at back nearly 1,000 years, the most volcanically perturbed atmosphere is right here in the second half of the 13th century. It's like a machine gun going off. There's a whole bunch of very, very powerful eruptions, and those eruptions are so closely spaced together that the cumulative effect on climate can be much, much stronger than just one individual event. And that's why it's speculated that this period of volcanism in the second half of the 13th century might have been the trigger for the Little Ice Age.
These eruptions could have shifted global weather patterns so much that Britain cooled down slightly for several centuries. But that's not the whole story. Skipping forward on the frozen timeline to 1815, we find the largest eruption in recorded history. Tambora in Indonesia. This eruption had a huge impact on our weather.
The temperatures in the summer in the Northern Hemisphere dropped quite significantly, and these drops in temperature had an impact on crops, and so people were really, really suffering.
The cold summer caused widespread famine that killed hundreds of thousands in the Northern Hemisphere, but the following winter was not actually that cold at all. That means volcanic activity can explain some aspects of the Little Ice Age, but it can't explain Britain's extremely cold winters. But recent discoveries may have found another key factor. Our worst winters could be linked not to anything on Earth, but to extraordinary features on our nearest star. There might even be signs that the Little Ice Age is coming back. When Britain is battered by extreme weather, it always makes headlines.
Hundreds of homes up and down the country's west coast are flooded. Miles of coastline roads and fields are underwater.
A year before the storms, the breaking news was the blizzards.
It's down further south where the main activity is going to be as this rain comes further inland, turning to snow across the east of Wales, the West Midlands and also central southern England.
But it's hard to beat the lead story in 1684, when the River Thames froze over for 2 months. That was in the middle of the Little Ice Age and the coldest winter ever recorded. We know that our weather largely depends on the course of the jet stream. And now recent discoveries have revealed a force that might play a part in determining what path the jet stream takes. One of our biggest breakthroughs in understanding our winter weather has come not from studying the atmosphere, but from looking way beyond it at our nearest star. To find out more, I've come to the Bayford-Bury Observatory in Hertfordshire to meet astrophysicist Dr. Lucy Green. Using the latest images, she's investigated strange phenomena on the surface of the sun that may have a powerful influence on the weather we get.
Okay, so.
Wow, this is a pretty impressive telescope. Shame we can't see the sun today because of the clouds.
No sun today, but it's okay because we have telescopes in space all the time, far above the clouds, that give us a constant view of the sun. And that's what I've got showing here in this movie. And what's most obvious about the sun in visible light are these wonderful dark spots on the surface that we call sunspots.
Sunspots are cooler areas that appear to float on the surface of the sun. They're caused by magnetic fields that come and go, and they can last a few days or many months.
You would think that when these sunspots form, that the sun dims a little bit.
Yeah, naturally, that's what you think.
But actually, that's not the case. Whereas in the centre of the sunspots, it's cooler and darker, in the region around, you've actually got more dispersed magnetic fields, and it gets hotter there. So when there are more sunspots on the sun is actually giving off a little bit more light.
So more sunspots means more light and more heat. And we should be able to tell if they affect our weather, because ever since the invention of the telescope, astronomers have recorded the number of sunspots.
These are drawings of sunspots from the very early years of the telescope. So these drawings are from 1611. And by using drawings like this, it means we can do something as simple as count the number of sunspots on the surface of the sun. And then we can draw a graph. And what we see, so this is going from about 1610 all the way up to the modern era. And you can see the number of sunspots rises and falls and rises and falls.
Each individual cycle of sunspot activity lasts about 11 years. But there seems to be a problem with one part of the graph.
What's this gap here then? Because this seems a little bit unfortunate.
Yes, absolutely. So this is the sun going quiet here. So it wasn't that astronomers sort of got bored of studying the sun and they didn't make any drawings. These newly discovered features suddenly disappeared from the surface of the sun. And they were absent from the sun between about 1645 and 1715. And this is a time that is now referred to as the Maunder minimum, so named after the astronomer who actually realised that the sunspots diminished in number during this time.
Even though astronomers continue to look for them, the sunspots just disappeared. And while the dates of the Maunder minimum do line up with the coldest part of the Little Ice Age, it was only when pictures began to come back from telescopes in space that scientists realised just how much difference sunspots could make. Because these images, taken not in normal visible light, but just in the ultraviolet spectrum, revealed that sunspots actually give off a massive amount of ultraviolet light.
The reason for that is because above these sunspots there are hot gases that shine brightly in ultraviolet light. So more sunspots, more ultraviolet light. And that could be the key to the unusual weather that we've been having in Northern Europe.
That's because the amount of ultraviolet light could influence the conditions that control the jet stream. When the ultraviolet light reaches Earth, most of it is absorbed in the upper atmosphere called the stratosphere. This absorption process heats up the air, but it doesn't do it evenly. So some areas of the atmosphere become warmer than others, and these temperature differences cause it to circulate. So the amount of UV light affects how much the atmosphere moves. That in turn can affect the circulation patterns lower down in the atmosphere, which is where the jet stream runs.
I mean, this is really new science. We're still trying to understand how this works, but circulation patterns high up might, for example, affect the position of the jet stream, which then affects whether we have warm air coming into Northern Europe or cold air coming into Northern Europe.
If this new science holds up, then the number of sunspots could have a big influence on the position of the jet stream and the weather we get.
So at the moment, the jet stream isn't really playing ball and we've had a lot of stormy weather. How do you think things are playing out at the moment then?
Yeah, it's a good question. So, because actually the sun's been doing something unexpected. So actually my graph here only goes up to sort of just after 2000. So let me draw on where we are with the sunspot cycle now.
Okay.
So here we are in 2014 at solar maximum. But what you can see is it's very small.
Yeah.
Much smaller than the previous cycles. And this may be the underlying cause of this strange weather we've had in Northern Europe.
The last time the solar maximum was as low as this was in the early part of the 19th century, when Charles Dickens was growing up. But exactly how this lower number of sunspots affects the jet stream is not yet clear. Recently, it's been driving mild, stormy weather our way, though in the long term, there are signs that our weather could get colder.
And we could extrapolate into the future and say, okay, well, if this decline in solar activity continues, could we end up back in a Maunder minimum-like state? And there's a fairly decent chance that we might
We
end
might
up
actually fall into another cold period then.
another Maunder minimum. That's right.
The last time there was a Maunder minimum, we had the Little Ice Age and the Thames froze. However, the science is new and not everything fits in. The winters of 1962 to 63 and 1947 were in periods when the solar activity was quite vigorous. Though if reduced solar activity does make the jet stream more likely to veer to the south, we should now prepare for more Arctic blasts. Learn how to deal with Siberian snowdrifts.
Oh my God!
And come to terms with life in a deep freeze. But of course, there's now another factor, making the picture even more complex. Us. All the carbon dioxide and other greenhouse gases we've pumped into the atmosphere trap heat and cause temperatures to rise. Recent figures from the Intergovernmental Panel on Climate Change predict a global rise of between 3 and 5 degrees centigrade by the end of this century. But exactly how that will affect our winter weather is unclear. We still need more research.
It's an incredibly complex picture because every winter there are so many different factors controlling the temperature at any one time. But the more we learn about winters in our past and the science behind them,
the more complex the picture becomes. And we realise that predicting what weather we'll get in the future is an almost impossible task.
Next, no contact, no technology, no independent artisan coffee shops where you can get a single shot of Americano with just the right amount of foam. 13 British blokes, one island abandoned by Bear Grylls for one entire month. Brand new, not to be missed.